Right, this video is going to talk you through an example of how to calculate the theoretical yield. So the theoretical yield, or which is sometimes called the predicted yield, is how much of a chemical we should get if every single reactant molecule is turned into the product. So if everything goes completely 100% perfect, how much product would you actually make? And that's called the theoretical yield in the textbook, but sometimes it's also called the predicted yield. So there's two ways you can do this. You can do this by using ratios, or you can do it by using the moles. I'm going to show you both methods for this one example. So in this example, it's asking what mass of hydrogen is produced when 192 grams of magnesium is reacted with hydrochloric acid. And it's giving you the balanced chemical equation in this case. So if it doesn't give you the balanced chemical equation, you're going to have to write that out from first principles. So of the two methods, I think the ratio method is the best, which is why I'm going to show you that. And that's because for this method, you don't need to remember any formulae. So what I need to do is write the information I've got in the question. So it's asking me what mass of hydrogen. So I'm going to put a question mark next to that because that's what I want to work out. And it's telling me that I've got 192 grams of magnesium. So I can ignore the HCl and I can ignore the MgCl2 because that's not involved in the calculation. I just need, it tells me how much magnesium is used and it wants me to work out the hydrogen. So for the ratio method, so I'm just going to write this equation out again. So for the ratio method, what you need to do is write out the relative formula masses of the two species that we are interested in. So for this case, I'm interested in the magnesium and I'm interested in the hydrogen. So if I look in the periodic table, remember you're looking for the relative atomic mass, you're looking at the biggest of the two numbers. And if I look in the periodic table, for magnesium, the biggest of the two numbers is 24.3 if we're using our datasheet periodic table that we need to use for the exams. If you look at some online ones, it might be rounded to 24, but we need to use the periodic table that we need to use in the exams. And if I look at hydrogen, in the periodic table, the relative atomic mass of that is 1, but that little 2 there means I need 2 of them, so it's 2 times 1, which is going to be 2. Now, we're not using it in this case, but if I was working out the HCl, because there's a 2 there, I'd have to multiply the mass of the HCl by 2 for this method. Right, so what this means, if we think about conservation of mass, is that 24.3 grams of magnesium will make me 2 grams of hydrogen. And what I want to know is how much 192 grams will make. So if we can use ratios for this, so if 24.3 grams makes 2 grams, then if I was to use 1 gram of magnesium, so to get from 24.3 to 1, I've divided by 24.3. So I need to divide this side by 24.3 as well. So 1 gram of magnesium would give me 2 divided by 24.3 grams of hydrogen. Then, if I look in the question, I want to know what 192 grams would give. So if 1 gram gives that much, then 192 grams is going to give 192 times that amount. So I times that side by 192. I need to times this side by 192. So that will give me 2 times 192 over 24.3. And if I stick that grams of hydrogen, and if I stick that into my calculator, I will get 15.8 grams of hydrogen is produced. And that's what I was trying to find out for the question. So that's the first method, which I think is the easiest one because you don't need to remember any formula. But I'm going to show you a second method, which is the moles method. So if you're using this method, you need to draw yourself a table like this. So you have the chemical, you have the number of moles, the mass, and the relative formula mass. So the two chemicals I'm interested in are magnesium, because it tells me the mass of that. So in here I can fill in that the mass, because it tells me in the question, is 192 grams. And then the hydrogen is the one I'm trying to work out. And we don't know the number of moles, and we don't know the mass for that. Now for the magnesium, so for the MR, so the MR table column I'm going to fill in first. So for magnesium, as we said on the previous method, if I look in the periodic table, the biggest number for magnesium is 24.3. And for hydrogen, it was 2, because remember, it was relative atomic mass of 1, but there's 2 of them, so I need to times that by 2. It gives 2. So now I've filled in that table, I need to use the equation number of moles is mass over MR. And this is why I think this method isn't as good, because I've got to remember this equation. So if you haven't already, learn that equation. So because I've got the mass and the MR for magnesium, I can work out the number of moles. So my number of moles is going to be the mass, which is this 192, over the MR, which is this 24.3. And if I type that into my calculator, 192 divided by 24.3 is going to be 7.9. Now I need to look in the equation. So if we think back to when we did moles, the balance equation tells us the ratio of the moles of our reactants and products. So this equation, because there's no number in front of magnesium and there's no number in front of hydrogen, that means 1 mole of magnesium makes 1 mole of hydrogen. So if I've got 7.9 moles of magnesium, I'm also going to have that's going to make 7.9 moles of hydrogen. So if I was using HCl, so if I had 2 moles of HCl, that's going to make 1 mole of hydrogen. So if I had 7.9 moles of that HCl, I'd have to divide that by 2 to work out how much hydrogen there was. So now if we look at my table, I know the number of moles and I know the MR. So now I can work out the mass, because if I look at this equation and rearrange it, I can rearrange that to give mass equals number of moles times by MR. So that's going to be my number of moles here, which is 7.9, times by my MR, which is 2. And if I put that in my calculator, that will give me 15.8 grams, which happily is the same answer that we got from the other method. Okay, thank you for listening. See you next time.